So if we remember from yesterday, if we're calculating pH, we take the negative log of the concentration of hydrogen ions. We don't have to understand what a log is. We just need to be able to type it in our calculator. So if I have pH is the negative log of the hydrogen ions. POH is the negative log of the hydroxide ions. POH is the negative log of the hydroxide ions. pH is also equal to POH, or 14 minus POH. And POH is equal to 14 minus pH. We just have to know how to type them in the calculator. We don't have to understand them. Yeah. Algebra 2. Good old Algebra 2. And if I want to go backwards from logs, H plus. If I want to get H plus, and I have pH, H plus equals 10 to the negative pH. That's the opposite of a log. So if I want to get back to hydrogen ions, I take the 10 to the negative pH power. If I want hydroxide ions, that's 10 to the negative POH power. So you just got to remember these 6 equations. And really, these are the same algebra-wise. You could solve. If you can remember one of them, you can remember the other. So if we look at the assignment from yesterday, we had a big table. We had H plus up here, pH, OH minus here, POH, and then acid or base. We didn't have a last one. And so the first one, it gave us H plus, which is 1 times 10 to the negative 6. And so we're going to calculate pH. For pH equals negative log of H plus. So pH is going to equal negative log of 1 times 10 to the 6th, or negative 6. So then I just go to my calculator. I type in negative log 1 times 10 to the negative 6. and I get 6. For my pH. Then for my pOH, I remember my pOH equals 14 minus pH. So I get 14 minus 6 is 8. Is this an acid or a base? If pH is less than 7, it's an acid. If pH is bigger than 7, it's a base. Which one is this? It's an acid. pH is 6, so it's an acid. pH is less than 7. People get pH and pOH confused. Don't think about pH when you're thinking about acids or bases. It does the opposite, so it will confuse you. Then last step, to get OH, I take 10 to the negative pOH. So that's going to give me 10 to the negative 8. If I get a decimal here in my exponent, then I'm going to type it in my calculator. If I get a whole number here, I'm not going to type it in my calculator. I'm just going to write it because it's already in scientific notation. I'll just write 10 to the negative 8. So the next one gives us the pH. The pH is 9. So without thinking, I know that 9 means it's got to be a base. And so I'm going to calculate concentration of hydrogen ions first. That's going to be 10 to the negative pH. So that equals 10 to the negative 9. I can calculate pOH equals 14 minus pH. So 14 minus 9 gives me 5. And then OH equals 10 to the negative pOH equals 10 to the negative 5. So the next one, I've got OH. OH is 4 times 10 to the negative 6 on the worksheet. The first step, I'll find pOH. pOH equals negative log of OH. 4 times 10 to the negative 6. That's pOH equals negative log. I type that in my calculator. Four times 10 to the negative 6. And I get 5.4. So my pOH is 5.4. To get my pH, I take pH equals 14 minus pOH. So I take 14 minus 5.4. And that should equal 8.6. because pH is bigger than 7, it's going to be a base. And then last step to find the hydrogen concentration, H equals 10 to the negative 8.6. And because there's a decimal in my exponent, I'm going to go ahead and type that in my calculator. And I get 2.5 times 10 to the negative 9. As my concentration, my molarity of H. And the last one, my POH equals 2.6. So my OH equals 10 to the negative 2.6, 10 to the negative POH. Go ahead and type that in my calculator, 10 to the negative 2.6. I get 0.003 when I round. Then I find my pH. My pH equals POH, or 14 minus POH. So 14 minus 2.6 should equal 11.4. Once again, I'm bigger than 7, so I'm basic. Last step to get H is 10 to the negative 11.4. And I get 4.0 times 10 to the negative 12.